Folks, we're getting going early here, so just sit tight. Looks like we're live on Restream. And YouTube's just started going. I think I set it up correctly on the latency, hopefully. We're a little early, but we got together a little bit early to make sure that we could have our guest with us, which we can formally introduce after housekeeping, which I do wait till 2 o'clock for. But we'll say hello to folks in the chats here. So Gaza Croy says hello from YouTube. Thank you, thank you. Welcome. I guess an early introduction is that the person up in the corner here is Dan Halbert, who works on CircuitPython with me. We can do some more discussions. Hi, Microdev. Yeah, we're early, Unexpected Maker. Hello, good morning. We won't actually get going for a little bit while longer, but Dan and I got everything set up early, and Dan can't actually see me. So getting the stream going means that Dan can see what's going on. So good morning, Dave.
Right, I can see you on YouTube, but it's about 15 seconds behind.
Yeah, that's why I'm like, don't use the audio. The audio is gonna be.
Yeah.
I thought I usually set it to low latency, so hopefully it's not too bad.
Or seeing myself, like I move my head and it's like.
Right. It's doing a big old round trip.
Out, right, yeah.
Hi, David G. Hi, Bruce S. Hi, Simon. Hi, Johnny. Said hi to Dave. Hey, Eric. Hi, Keith E. Things are going good. We're going to talk about all the stuff Dan's been doing. Yep, you got time to get coffee, Gazakroy. We got about 6 minutes until I want to do housekeeping. Although, let's see if I can... Is cat cam going? There's a giant kitty. She's hiding behind the monitor. Let's go back to this. The cleaners are in the house and she's scared of them. She's going back to her bed. So yeah, start brainstorming questions for Dan and I. Giant cat attack, I know, right? Ooh, chili onto the stove. Bruce, that sounds amazing. Hi, Juan. We were just thinking we hadn't done veggie chili this winter yet. Okay, it looks like Twitch is online. For some reason, the title doesn't work on Twitch anymore. And if somebody could just drop a note in the Twitch chat or even the Periscope or LinkedIn chats just to make sure that I've got that set up right, that would be awesome. And Dan, why didn't you say something to make sure people can...
Can you, yeah, how's my audio for people?
Yeah, can folks hear Dan? Thank you, Stringlabs. I'm not entirely sure I have permissions to change the title on Twitch, so sorry. But thank you, Stringlabs, for letting me know the chat's working. And you can hear Dan fine. Great.
Okay, good.
Thank you, Anthony, as well. KMatch98 is in the Discord chat and says, looking forward to the live stream watching on Twitch. Thanks for agreeing to talk about ParallelBus. Yeah, it's on the list. We'll try to get to it sooner rather than later, but as you folks know, we do take questions. So if you have any questions now, now is totally fine for questions. I will do housekeeping in 3 minutes or so, which is like introductions and when this happens and all that. But before that, if you do have any questions, oh, Ski, sorry for the super loud ad on Twitch. I do try to turn off monetization on YouTube, so hopefully you don't get ads on YouTube. Oh, is the Discord object thing happening again? It's a bug. It was a bug last week too. Unexpected Maker asks, and let me take a time code on this. Any further work or investigation on pinalarm in current use? So do you want to answer that one, Dan?
I have not worked on it anymore because I've been working on getting the next release candidate out.
But we did figure out what the problem was, right?
For touch alarm. Microdev fit touch alarm even when it was not in use was turned on, and so the lowest that Deep Sleep would go was like 2.5 milliamps. But then Microdev fixed that, and it's back down to like 230. In fact, it's even lower. It's like 230 microamps now. I'm not sure why. It was like 260 before, and now it's 230, and I'm not really sure why. So they might have fixed something else about how the peripherals are powered or something.
Do we update the IDF at all? I don't think we have, right?
No, but there's some extra calls to the sleep routines.
Oh, okay. That Microdev added?
Yeah, so maybe they're actually turning off some things that aren't in use.
Okay.
Something.
David G asks, will you have time to work on BLE issue 37 to support serial over BLE with other UUIDs other than Nordic?
I have done that already, but just by copying the code. One of the devices that I support uses serial over UART with some different UUIDs. I think it's like the iBarbecue thermometer, not the iBarbecue, some other device. But yes, it would be nice to be able to pass in different ones. I haven't done that. I just copied the class.
That's the beauty of open source, right?
Yeah.
Bruce Siegel said, we are all objects at our core in response to the bug of the StreamKit overlay. And Unexpected Maker says, okay, cool, thanks. Paul Target says hi, says, hey, all missed last week, so happy new year to everyone. And Anthony points out micro is 10 to the minus 6, right? Which I think sounds right.
Yes.
And Johnny says hi to
1 million, yeah.
And I'll just try to keep refreshing this StreamKit overlay as the objects come in there. And Bruce S is now in the Discord chat too. Okay, it's 2:00 here. This is when we get going, so let me pull up my notes for housekeeping, and I'll take a time code as well. So we'll take questions afterwards, obviously, but first let's do housekeeping. Hello, everyone. My name is Scott. I work for Adafruit on CircuitPython. With me is Dan Halbert. I always point the wrong way, in the upper left. We both are sponsored by Adafruit. That means we're paid full-time to work on CircuitPython. Adafruit, if you don't know, is an open source software and hardware company based out of New York. They sell lots of little boards that you can use to make projects and give your projects some code to make them do things. CircuitPython is the software that runs on lots of those products, and it's geared towards making it really, really easy to program to make it do what you want. So if you want to support us, please support Adafruit by going to adafruit.com, purchasing some cool hardware there. We're in a lot of chats here. I've got most of them pulled up. But what you can see on the screen is the YouTube chat and the Discord chat. The Discord chat has a bug. That's why it's object. If you want to join us on Discord, we're there both like now and throughout the week. You can go to the URL adafru.it/discord, hop in there and chat with us all the time. That's where discussion for development of CircuitPython occurs. So check that out. This is a deep dive. I do these every week. They happen normally on Fridays at 2 p.m. Pacific for about 2 hours, usually till 4 p.m. Pacific, or even longer if I don't have anything afterwards. So if you have questions, feel free to ask them, and we'll pause. We'll take a time code so that people can see where the questions are in the long 2-hour stream. and then we'll answer it. And today you get a bonus because we have Dan here in addition to myself. So hopefully you have lots of questions. We do have lots of work we want to show as well. So don't worry if you don't have questions immediately. Next week will be on Friday at the same time as well. Occasionally I shift to Thursdays because I want to take Fridays off, but next week will be on Friday too. And last up, both cats are in the room with me here. Cat cam might be pointed. You can see there's Vin in the bed there. But her brother, Spook, is epileptic, and he does have seizures from time to time. It's unlikely, very unlikely that he has one today, but I just like to give people a heads up. If I'm like on stream but not talking to the stream, that means I'm just like making sure he's okay. And with that, I think that's all the housekeeping. Our plan is to answer any questions you have. But I think first let's actually let Dan introduce himself, and maybe we can talk about how Dan got into CircuitPython, that sort of thing.
Sure. Okay. So yeah, I'm Dan Halbert, and I've been getting paid by Adafruit since August of 2017 to work on CircuitPython. But I actually started using CircuitPython maybe 6 or 9 months before that. I was helping somebody with an assistive technology project. There was a guy I know who's a filmmaker who also has cerebral palsy, and his hands don't work too well. His feet, he can use his feet to push buttons on the floor, but at the time he was just using a single button to represent a mouse click, and he was using a chin-operated joystick to move the mouse around on the screen. And he's a filmmaker, and this was an extremely slow way of editing things in like Adobe Premiere or something like that, like doing the drop-down menus. But you know that programs like that have a lot of keyboard shortcuts, and he really wanted some kind of like multi-button scheme to be able to do keyboard shortcuts. So I said, I can build something for you like that. And I had been getting familiar with CircuitPython, and I said, it's so neat, I could make it so that you could edit the keyboard mappings later, even if I wasn't there, because you can use the CircuitPy drive and just have this file that reads the keyboard mappings. So I did build this thing for him, and I was using the built-in HID stuff that was in CircuitPython that Scott put in really early. And I found some bugs in that, and I fixed them, and I ended up being like a volunteer contributor to CircuitPython. And then at some point I said it would be great to have this as a job. And long story short, I ended up with it as a job, and I've had it for more than 3 years now. So it's wonderful.
Yeah.
That's the story. I mean, I have a long history. I just did something on Show and Tell where I had written my first program 50 years ago last year. So I've been doing different kinds of software and some hardware for a long time.
Yeah, and not only that, right? Like you showed me this video from your time at Xerox PARC where you were experimenting with ways for people to program their computers, like usually. What did you call it? Like visual programming?
End user right. I worked on something called programming by example.
Right.
Which was like programming in the user interface by giving an example. And it was on this Xerox Star system, which was the first desktop metaphor system, which means like icons on a desktop. And I had a simulation of that was written in Smalltalk. But I've always been interested in like programming for non-programmers, and so CircuitPython fits right into that.
Yeah, which is awesome.
Great. Yeah.
And since we're talking about your history now, Dan, David G wants to hear the Moore story.
Oh, okay. Yeah, the Moore story. So, those of you who use Unix or Linux or even MS-DOS, there's a Moore command that prints out a page of stuff and then prints Moore at the bottom of the screen. And so I was the one who wrote the first version of that command for Unix when I was a grad student at Berkeley 42 years ago. Okay. And at the time, the Moore command had one of the longest names for a Unix command because it was 4 letters long. It was actually a real word.
What? Yeah. You didn't drop a random letter to make it shorter?
No, I didn't. Right. I didn't. Yeah. So less came after more. I actually had written a joke version of more called less, which painted up the screen, but that was just a joke.
Yeah, and I think the reason I wanted to point out the programming by example is really like you've had this goal or desire to be like making computers more accessible, and that
Yes, I've always really been interested in that. Yeah.
right. And
Yeah.
so it was really great for me. Like I was the first person that Adafruit hired to kind of work full time on CircuitPython, and I think Dan was like the second. Like there was a couple key people that came into play in our community in that time period. Like Katney, I think Katney was around then, and Jerry N was kind of around then as well as Dan. And it's a huge benefit to CircuitPython for to go from like one core person to multiple core people. And it turned out that like Dan is also a really good compliment to me. Talking about doing bug fixing, I tend to be a bit reckless, and I was talking with Lamore and Phil, and Lamore was kind of like picturing me as like the person who like weed whacks through the forest, and then people come along and like make the trail nice afterwards. So it's been great working with Dan and having
Thank
him
you.
compliment me really well.
Same here. Yeah. Yeah. You're willing to do things that I was scared to do or something. So
Yeah.
that's works out really well. And it's really good just to have two people so we can review each other's code. Like
Yeah, totally. And
Scott
that was
didn't have somebody to review his pull requests at the beginning. So
right. And I knew the moment that we had somebody that was there to do that, we would set up this process of like doing a CI and pull requests and all of that stuff. Um, so Gareth Coleman asks, Node-RED are interested in your opinion, and I think they're talking about using Node-RED as a way to program. I
uh,
don't know if you've used it at all.
I looked at it about 10 years ago, but I sorry.
Yeah, I know
It was
I've
for a
taken.
job I used to have. Yeah.
Yeah, I know I've taken a look at it before too, and I know that it's kind of comes up in maker circles with the teensy audio stuff. But I think if people, I think it. What is your website like? Halbert.org.
danhalbert.org.
Like the video for the program by example is on there, right?
No, and David S. Are we in the same time zone?
No,
We're not.
Dan
We're
is on the
3 hours.
East Coast.
Yeah. We're facing different oceans.
So if I just if I superimpose, I think this younger Dan, I think we can actually. I don't know what the copyright. So
Don't worry about it. I have permission. I got permission.
Hi, I'm Dan Halbert, and I work for the Office Systems Division of the Xerox Corporation. I'm going to tell you about a
Before I
technique of
needed
programming
glasses.
called programming by example. The basic idea of
There you
programming by
go.
example is that the user writes a
Yeah.
program by giving an
so
example.
let's just
Now, this program looks very similar to the program that I
So,
recorded
yeah.
just a minute ago,
This is from
except that it's
1984.
moving the document
So-
named Grand Canyon onto the desktop instead of the document named Zion.
I won't
But
play the
that's not
whole
what I
thing
want.
because it's
Sure.
13 minutes long.
But you can see I'm demonstrating my thesis project here,
Right.
which is so I'm moving icons around on the desktop and it's creating a script of what I did. And then you can play back the script and alter it and generalize it.
Right. Which I think is really cool, and I think I just actually let's see, what do we want to do next? So we should answer K-Match's question in case they can't stay for the whole 2 hours. But I do want to talk about CircuitPython 2021 as well, which I know that you posted yours earlier this week, and I managed to get mine out today. So that is something I want us to talk about, and maybe that can be like a continuation of this discussion about this stuff. But let's just dive into some deeper stuff a bit. So let me take a time code. So KMatch98 is a person in our community who's been doing some really cool work, especially around display I/O. And they asked on a GitHub issue, say, hey, can you, I'm wishing that I had a way to keep you in the top left while I while I show my desktop. Let me add another thing here.
Well, I could share a tiny. Could share a small window. No, I guess I can't do that.
Okay. Sorry for the flashing.
That's all right.
Desktop with guest 2. So let's shrink me
Trying to
down.
type really quietly.
This is Discord video, but it's... Oh, okay. So... if I move this... My screen is too small for this, turns out. I have to like have certain windows above other windows. Screen capture, add existing. Okay. Maybe I just stay down here.
If I unshare my screen, does that help any? I don't...
No, I think I just don't have enough windows.
Okay.
Like I don't have enough room, because I think your video starts flickering if it's covered up. Like if I do this.
Am I already popped out?
Yeah, you're popped out already.
Okay.
All right, let's just go with this. This looks okay. Yeah, I'm not used to having so many screens. Okay, so KMatch98 asked on this issue if we could cover. So this is a display.io parallel bus is not supported on the ESP32S2, which I know people would be interested in, since a lot of the folks. You need one of those boxes that puts 4 HDMI streams into one. Yeah, maybe I do need like another monitor. It'd be kind of obscene. I have an ultra wide already that I usually fill up. Oh yeah, I thought this would be really interesting. Oh, this is part of the other problem. Is that let me move everything over here. Otherwise, I have to have the window closer. There we go. Hi, Hugo. We're just getting set up for having a guest on. Maybe because of tabs, that's okay to have me there. This is good. Dan's the guinea pig for having guests on the show. All right, that'll do. Okay, so I thought this would be interesting. I don't know if it's super readable, so I'll just kind of read it off. So there's this issue for ParallelBus not supported on the S2. So what a ParallelBus is for displays that have, it's known as like the RGB, no, it's the 8080 parallel interface, where typically you'll have displays that'll be like basically a SPI device, and it will just use one data line to transmit like the commands. But what you can do is you can have more lines on that in parallel to make the data go faster. So we have this class called ParallelBus. We use it just kind of like only the PyPortal, I think, uses ParallelBus. But the idea is that you could just transmit data faster, which means that you can refresh the screen faster. And so KMatch98 has this open issue about adding support to the ESP32S2 for the ParallelBus stuff. And so I thought it would be like somewhat straightforward. And they just asked for some clarity on like where to go. So look, there's links here to the SAMD version and the NRF 52840 version. And then there's this copy of this diagram here, which maybe if I click it, I can make it a little bit bigger. So this is out of the ESP32S datasheet. And I thought it would actually be interesting to just talk this over as a hopefully like making it a little clearer to K-Match about how it works. So what happens, or usually how microcontrollers are and probably microprocessors work, is that you can kind of think of the right side here as like the edge of the chip. So these are the pads that are actually driving like the signals to the outside world. And then there's like inner things that are like much lower voltage and less power that happen inside of that to tell the pad what to do. And so if we're looking at the right hand side here, there's like two different pad diagrams, and they say that they're supplied by different power supplies. So that's an interesting thing. This is of course custom to the ESP32S2. Then one thing they're also showing is that there's actually two ways internally that the pad would be decided what the value it outputs is. One way is through this like complicated system here that is in the like main power domain, but then there's also a separate real-time clock domain sort of thing. So this RTC GPIO and the IO mux there. So basically what we're searching for ParallelBus is how do we manually set the values that we want to end up with on the outside of the pad. So if we just take a look one step in, there is an IO mux. And so this is actually the common part of the way that IO systems in most of the microcontrollers I've looked at work, where the IO mux is selecting between a number of incoming signals from a number of the like peripherals internal to the chip, and its job is to select amongst those. So that's what this IO mux thing is. And then there's also like if there's input signal filtering that happens at this stage as well. And if we look more closely, it's actually both the input and output values that are routed through the IO mux. And then the S2 is a little bit weird in that it also has a second level like mux that happens in the GPIO thing, and it's really flexible, which is great, but it's slower. And so if I'm looking at this diagram, there's this so this is all the input. This is the input mux and deciding it on how it goes into the peripherals, and then here's the chain that dictates the outputs. No sound. Can you folks hear me still?
That's where I muted myself. Did it turn off your sound?
I don't think so. Okay, Mr. Certainly can hear me still.
Okay.
All right, thanks, folks. Yeah, sound is okay. Okay, so there's signals here that are input from peripherals, but then there's also this GPIO out data bit X. Thank you. You all are so awesome. Confirming that you can hear me. And this Discord thing, it's a shame that it's still not working. But yeah, so this GPIO data bit is actually the thing that dictates kind of like if you want to just set what the value is with the processor, then you do that. And usually what happens on the is that you just write a single register, and like bit 1 is pin 1 and bit 2 is pin 2 and so on, which means that if you have 8 pins in a row, you could just write directly to that and you set them all at the same time. This actually makes me worry a little bit that that's not the case on the ESP32S2, but I suspect it's probably okay. And so to implement ParallelBus, to circle back to where we're going, basically you just have to configure the two muxes, the IO mux and the GPIO mux, to just like take the value of that register and output it. And then the simple GPIO output. Yeah, so that's what this says here is the GPIO matrix can also be used for a simple GPIO output. This can be done by selecting the GPIO out function selection in the GPIO matrix and then setting the corresponding bit in the output register. And there's two output registers because there's more than two or more than 32 output bits. So I guess I would say to K-Match, I think you're on the right track. Basically, the way ParallelBus is, you'll like twiddle some things and then write to that register. So yeah, K-Match, do you have any other questions about that? I know that's not like super detailed, but I think you're on the right track. Juan Carlos asks, I think I missed it earlier, but is ParallelBus something that doesn't exist for other boards, or it exists and you are extending it to the ESP32S2? Yeah, so it's an existing API that we have. It's under display IO, which makes it a little funky that like it's one of those weird classes where we don't always implement it, but it's usually there. So like if you try to construct it, then it will just like raise a not implemented exception. But yes, it exists. So it's like one of those things where like all the APIs are laid out and we have example code. It's just that we haven't ported it or implemented it on this particular port. Yeah, I think one of the things that is tricky about working with the IDF is that and Dan and I can have this debate because we have different opinions about what we should do, but I tend to not like to use vendor APIs because it abstracts away from like the reality of like the registers. And Bruce S is getting to this too. It says, what level of the IDF will be used? The published API or something lower? Yeah, so I mean, the question is like, what is the IDF's API? So if we just do, like, maybe we can find out what component it's in. So if we just do components, so there's a couple ways you can find it. One way we could actually look is just to try to find like a reference to the name of the output register. And this, I'm really happy that it's all open source. It's not like a binary blob. But if we just search for GPIO out register here, we can see all the references to it. So this is kind of the very basic, and look at this. This is the ESP32C3. So if you want to know like the structure of these chips that aren't actually released yet. Yeah, Bruce S points out, in some cases, Espressif may fix silicon errata in the IDF. That is true. It is interesting that it looks like I don't see any code that actually references it, which seems kind of hard to believe to me. Like there's the same register on the C3, the S2, and the S3. Oh, good. Emmett got the sound figured out. On the issue, you pointed to GPIO struct as one of the main structures. Yeah, so I think if we go to include sock GPIO register, there's probably a file next to it for the struct. And that's kind of my preferred way to use it is via the struct. So yeah, so there's this GPIO struct. This is really common for vendors to provide. Basically what they do is they present a struct that maps like the memory of the peripheral to like a C structure, which I actually like really prefer. So yeah, there's an out one register, out one TS. So TS is probably set, TC is clear. It's pretty common to have like separate registers where like if you write a 1, it actually sets a 0. It means that you don't have to like read the value of the register and change it and write it back, which is actually kind of a tough thing to pull off. But yeah. So yeah, I think that's what I would do. I don't know if there is actually like a... I guess the ESP IDF docs are pretty good. I don't know what the GPIO... dedicated... Right, so it can be accessed by CPIO instructions directly, which is what we want, and simulate serial and parallel interfaces in a bit bang way. Like that's definitely what we want. So if you wanted to use something higher level, this could do it. I'm not exactly sure how to use it, but it's documented. Bruce S. says, I'm just reading about the dedicated GPIO stuff. It's interesting. Paul says, wow, I was just reading about doing the clear register thing on a tiny 1607 this week. Small world. Cool. Awesome. K-Match is going to take a look and then circle back with more questions. So, you know, I like to emphasize, folks, if you want to get started with CircuitPython and hacking on it, Dan and I are both here, along with Jeff and the other folks on Discord for guidance. So if you are trying to get into the weeds of and dive deep into the source of CircuitPython, like we're here to help. We may push back on if you say like, hey, you should do this task, we'll push back on that. But if you say, I want to do this task, can you get me started? We're always happy to do that. Okay, let's take a time code and let's kick it over to Dan to let us know what all of the awesome stuff that he's been working on. Unless you want to talk CircuitPython 2020, or do we want to stay deep?
Yeah, we could do that first because I don't know where to start and end.
Okay. All right, let's talk CircuitPython 2021 before we get back into... So David G asks, what would be the best MCU to start with? I don't know what... It depends on what you're trying to do, I guess. The Cortex M01s are simpler than the M4s or the M7s. The M7s are really complicated. Ooh, Tim says, I'm hacking on a Whiskey server for WizNet 5K. That'd be cool. To learn coding the CP core, probably the M4 actually, because the M4s are usually large enough for you to do debug builds. The SAMD21s are tricky because they're basically full. Learning to avoid the IDF. It's a bad habit of mine to avoid the IDF.
Yeah, the problem... It's good to have an idea. It's good to have something like the IDF that's nicely constructed. And the problem is when there are bad SDKs instead of good SDKs. I think that's kind of how I feel.
Yeah, and I mean, one of my issues with it also is like all the SDKs are different, and I really want things that are uniform across all of the things that we work with. And to me, like finding structs that represent the peripherals that are documented in the data sheets is usually like the thing that's uniform about all these vendor things.
Yeah.
And like definitely got burned by ASF. Like maybe we should talk about this.
ASF3 was okay, I think, right? Or you would say it was and then that was just a regular software library that you could download. And then they went to this ASF4 thing, in which there was this web-based GUI that would generate a set of include files and a prune set of source files for only the things that you wanted to do. And that was terrible for us because that's all about, oh, you want to build a toaster, and inside there were the connections stay the same, and that's not what CircuitPython is like at all.
Well, they're actually doing like Jinja templates or something in Python, because I remember I was playing around with like our ability to update, and like I remember giving it like a JSON string to this service that like looked to be generating it, and I got an error message back from like Jinja that was trying to do all the templating stuff.
Right. Okay. Yeah. Like I would say the NRF SDK is actually, there's sort of two levels to it, but the simple one is really simple and is basically a nice set of include files and some libraries, like, so you don't have to write your own I2C driver or something if you don't want to.
Right.
So I would say NRFX, which is what that's actually a nice one to start with. That's kind of one of the cleanest ones there is.
Right. And I think generally the IDF is pretty good too.
Yeah, I would say the IDF is good. It's a little higher level, I'd say.
Yeah.
The STM ones there are too many variants on the STM chips. There are too many idiosyncrasies in there.
Yeah. The IDF is like has the added challenge of doing all the networking.
Yeah.
Like they require an RTOS and things like that. And they have a build system, and like build systems are another huge topic. Okay. That was a tangent, and you all know. The thing I don't like is that on the ESP you are just a process on an operating system, where I guess on the M4 you are bare metal. I think all this microcontroller stuff is still bare metal, because there's no memory protection at all. Like, it is true that like you're really a task in an operating system in the ESP. Like, there's no like real protection between you and other stuff, whereas like a real operating system would actually like isolate you. So I do consider it bare metal, but it is like harder to think about. Juan Carlos asks, so how much work would be required to set up an eink display that requires a parallel interface? Would one just have to enable ParallelBus for a custom board, or will it require more deep coding in CircuitPython codebase? Dan, do you want to try to answer that? Or should
I don't know a lot about the e-inks. I mean, many e-inks have very idiosyncratic control signals.
Yeah.
So it's not so much the ease with which you talk to them over a parallel bus or not, but all the code that you need to do the timing or raise this thing, or especially with e-inks, there's a lot of stuff about timing, I think, right? Because what e-inks are little balls of something that go up and down. And so you apply a charge, a higher or lower voltage, or you apply a charge for longer or less time, and the thing rises to the top, or doesn't quite rise to the top, or flips around,
right,
or something like that. So
yeah,
make them all hard to code for.
Well, that's all managed by the IC that's on the e-ink, and I think this is something that has been a bit frustrating for me doing all of our display work, is like, we don't always talk about the IC that's between the display and you. We kind of like historically treat the displays as like a display. And you have to dig a bit to understand that like there's an intermediate chip that has RAM that is running all of these things on it. Mm-hmm. And so my answer to one would just be like, it depends entirely on what the protocol that the e-ink is talking, and whether that would work. And then it got me thinking also about this e-ink that started to show up that's like the 7-color e-ink, which looks amazing. But like there's this whole other challenge of like figuring out like what color goes where, which is a bit weird and something we're going to want to do, I think, this year as well. Yeah. So another question. Benjamin Peng says, I have a Motor Shield V2 module. What is the best compatible SOC module except for Arduino, the best platform for CircuitPython? I don't know exactly what you mean.
Well, the Motor Shield, if it's Arduino shaped, then I would say like a Metro M4, which is this MD51, is a good platform for that because it has plenty of memory. If you wanted to talk on Wi-Fi, then you would use a Metro ESP32S2.
Mm-hmm.
And we don't have a Metro NRF, but we do have a Metro M4 Airlift, which has, well, so you could also use that to talk on Wi-Fi or Bluetooth.
Mm.
So all those things are possible choices for Ben.
Right. Okay. Thanks for, you know more about that than I do.
Sure.
So Juan just followed up and said, so basically for the displays Adafruit sells, you guys basically had to write something like a driver for it. There's no standard way to talk to displays. There are kind of like families, like standard families. So you will find like either displays have the same chip on them or like the chips work very similarly. But if you have ever looked at I think it's particularly the e-paper, but there's like a long list of keyword arguments that the native classes take in order to work with like quirks of these different chips. So yes, there tends to be like a semi-standard around how displays work, but then there's also like isolated like semi-standards, and like to hop to a new group is potentially a lot of work. So yeah, it all depends on the details. David G says, maybe an interesting question on the ESP32S2. What are the special hardware support that you have on older platforms that are not there on the ESP32S2 yet? Like fast Neopixel with DMA, Matrix Hub 75 with parallel writing byte on multiple GPIO, and rotary IO. Why is this special? It's just, I think generally it's just that there's like weird things that aren't often used in projects, and so they don't get necessarily done quickly. And then depending on how the chip itself works and what peripherals it has, it might be easy or hard to do. I know that the Hub 75 support is really tricky because it is actually like, it's very time sensitive because it's literally like from that chip you're doing PWM matrix E stuff. That's tough. Fast Neopixel with DMA. I think I don't know why people think this, but DMAing Neopixels doesn't help you that much because the you're rate limited by the speed of being able to transmit bits for Neopixel. Like Neopixel has a fixed timing, so DMA doesn't really help you. All the DMA does regarding Neopixel is that it isolates you from anything the CPU has to do besides the Neopixel stuff. So if you look in like SAMD21 Neopixel write, we actually turn interrupts off because we have to like know that we're going to be doing the CPU while we bit bang the pixels out. And then of course there's like the parallel Neopixel output stuff that we have as well, and that does use DMA. But that's also very weird because it has to like repack all the bits and stuff, and work a bit more like ParallelBus does as well.
It uses up a lot of memory to do the parallel stuff.
Right.
Do the DMA stuff.
Okay. Oh, had a mission a year or so back with tiny OLEDs where different ones had the same from the same vendor were mapped to different parts of the SSD memory. Had to do offset constants on X and Y. Yeah. Yep. Getting things differently. Like, it kind of blew my mind that like we had different drivers depending on like the tab of the screen protector color. It's like, no, that's not the best way to do it. We can talk about the chip and how it's connected instead of just the tab color. Good morning, Mike Causer. Ooh. People asking the hard questions. Davey Baker asks, is it feasible to do PID with a time of flight sensor and a stepper or DC motor feasible in CircuitPython? It's worth a try, but you won't know until you try it. We don't like we were talking about this, I think, in the stream last week, not Dan and I, but like us generally, about like how real time CircuitPython actually is. And it's not necessarily as real time as people think it is, because there's things that can happen in between, like things can happen that like sporadically slow your Python code down. So my philosophy is kind of like, try it. Our goal is to make it really easy and fast to try, but it doesn't necessarily mean it'll actually be able to do it for you. So try it, take an hour, try it, see if it works. If it doesn't work, then you can decide either to scrap CircuitPython, or you can figure out like what piece needs to happen internally that's quicker. Juan says, this explains why Sion kept going on about blue tab or green tab screens on one of his streams. Okay. CircuitPython 2021. Welcome to my stream, Dan, where we get distracted by good questions. So CircuitPython 2021, last week we talked all about it, all stream, so we don't need to recap. It's a thing we do every year. We try to get folks' opinion about what they would like to see, where CircuitPython should go as a broad thing. Some people take it to tell us as a time to tell us what we should be working on, which doesn't really jive well with me. But since Dan and I both work on it, I thought we should at least talk a little bit about what we are doing. So I think I can move Dan off here and move this back here. Trying to figure out Windows. So these are all the CircuitPython 2021 tags, and I just wanted to highlight, since last week, I think we got a few. We got thoughts from Benny E and Foamy Guy, thank you. And then Deshipu and Ask Patrick W, a post and an email. Dan, do you just want to shortly recap your thoughts?
Sure.
And how you feel about it? I know we talked about this a little bit too.
How do I feel? What do you mean, how do I feel about?
I'm thinking that you felt like it was like very similar to what you thought last year as well.
That's right. Well, this is the third time I've written one of these, and I was like, what I did the second time was go back and see what I wrote before to see, like, did my predictions or hopes come out? So it's true that it takes a while for things to go through. But for instance, BLE was at the top of the list for 2020, and I said, we did that. Great. Like I wanted to do. I said that in 2019, and we did it in 2020. So that was really nice. So Same thing here. We've been talking about sleep for a while, and the first thing I said is, yes, we've accomplished real low power sleep.
Right.
It's just one port, but we know how to do it now, and we're gonna do it for the other ports as soon as we get a chance. So that's still to be done, but if we can do it for a bunch of other ports, that'll be great.
Right. I would definitely like to do that.
And I think it's really opened up, especially with these, like the mag tag has been enormously popular, And it's opened up all these kinds of projects where you have something that runs all the time, or you can see what it says all the time, and you can update it only when you need to, which is infrequently, and it'll run on a battery forever, basically. That's really nice. You don't have to worry about USB cords hanging off your refrigerator or something.
Right.
So then the next thing that I talked about is something that has been in every one that I said, which is how do we respond to asynchronous events, and what do we do? And is there some way to do some kind of concurrency or multitasking? So we keep saying this would be nice, and we had now one or two people who've said, like, I really want this. I'm going to make sure that if I turn on the feature in MicroPython that enables this, the async and await keywords,
right,
that it worked properly. And so somebody did that for us. That was great. And that person also, I can't remember who it is off the bat. I'm sorry.
Warrior of Wire.
Warrior of Wire, yes. They also wrote a very simple library called Event-O, which is kind of like async IO distilled down to one page or something like that. And also Deshipu has done something similar. And so we haven't yet started to use those libraries to try to write things like simple programs that manage multiple Neopixel streams or something.
Right.
And how can we do that? And I think the other thing that came up when I was working on the alarm and sleep APIs is that I said, these are asynchronous events, these wake up things like waking up on a time, or a pin changing, or a touch happening. Those are all events. And right now we're just using the wake up from sleep, but we could also just put them into an event queue or otherwise trigger something to happen asynchronously. And so can we use the same kind of event structure to handle asynchronous events with an event loop?
Right.
So that's what I hope for, but I haven't had time to think about it.
Yeah, this is probably the longest issue we have for CircuitPython, right? Is that issue?
Yeah, right. Besides, the Windows doesn't write things out. Then another thing that's been on our agenda for a long time, which has come and gone and come back and gone again, is we have testing based from MicroPython that tests the functionality of the language implementation.
Right.
But we don't have testing about, like, we don't have automated testing for it. Is I2C still working on the NRF port?
Right.
Or something like that. And
or is
Scott
Bluetooth
built something called Rosie a long time ago that was based on a Raspberry Pi that was trying to run some tests. And it was never reliable enough to use. Unfortunately, it wasn't Scott's fault. It was kind of using a Raspberry Pi in a way that tended to wear out its SD card really fast, among other things. And so it would be nice to think about that again. It's like, how can we do a set of regression tests? Maybe not on every PR, but at least every once in a while, to make sure that when we put out a release, we haven't broken things.
Right.
And I don't know what the answer to that question is. Summersoft has also worked on that for a while, but it was also a slog. So that's an aspiration.
Yeah, I have had some contact with a startup that's trying to make this easier, and I've challenged them to doing it for CircuitPython. So I'm hoping we'll hear from them.
That would be great, because that's the ideal. That's a real existence proof. Yeah.
Yeah. My selling point to them was like, hey, like, we're an open source project and we have an audience. Like, it would be cool to see your stuff set up and doing that. I think it's tricky. I think that when I had a discussion with them, they're like, so would we just send the setup to you? And I'm like, no, I don't want the setup. Like, I don't want to have to even have boards in my house that are running this stuff. Like, I just want it to be all automated somewhere. So yeah, we'll see how that goes.
And David Glad points out our learn guides sort of get bit rot because interfaces change, things break, sometimes subtly, and it would be nice to maybe retest those. In fact, maybe those are probably good. I mean, the core of some of those would be good.
Right. We don't even necessarily need to test them on device to detect everything. Like we had this issue with wave file and raw sample being removed from audio IO, which we did really good. And we said like, oh, in 5x it'll be in both places. And then in 6x we'll remove it. But the problem is that we never went back and like changed everything over before we removed it.
Right. I mean, maybe we need to start labeling the code in the Learn guides with versions or something like that.
Yeah, yeah. I mean, that's the whole discussion of like version pinning, right? Like,
Yeah.
and I come from my background with Google is like, no, everybody should be on the latest, which is a challenge.
Right. So getting the stuff updated is hard, and retesting it once if it is updated, because often these are complicated projects that require a certain hardware setup that you can't replicate immediately.
Right.
And
Yeah,
so
PWM out is going to be in that boat too.
yeah. So then the last thing on my list was that it's great that we're adding so many boards to CircuitPython and we're adding new languages. And what that means is that we have that Cartesian product explosion where anytime you submit something for a PR, even if it's like a spelling correction, it causes 3,000 builds to get generated and uses up a number of hours of CPU time.
Something on the order of 24, right?
Yeah. So can we do better than that? Like, can we, for instance, maybe separate the translations from the board builds? I mean, I'm not sure what we can do to reduce the number of board builds unless we said these boards are identical, but they're not quite identical. It's really hard to say. I'm not sure that we could do that.
Right.
I've heard stories about Microsoft testing Windows where they have rooms full of many kinds of computers. And
I've heard similar stories from this, like silicon vendors as well. Like they just have board farms that they do.
yeah,
Like I know Espressif has that. I know, like I'm part of the Zephyr TSC, and I hear that like before they do that, the companies have to squirrel away and do their board level stuff as well.
I mean, would it make sense to classify certain boards as almost identical so that if no code changes in that board's tree file specific for that board, that we don't have to build that board? We only do it every day or something like that. I don't know. That's what people used to do, because when they couldn't, continuous integration it used to be that people would only do testing on a periodic basis, full testing, because it took too long.
Right.
So anyway, so that's the end of my list.
We just need more computers.
That's right.
That's the modern approach to it.
That's right.
Just like throw more machines at it. But there's some potentially interesting stuff we could do about like sharing compilation outputs and stuff like that.
Yeah. Are there right? How much work we're doing is completely duplicative. Like, could we cache certain results? We don't know. Scott and I talked about that for a while.
I have dreams.
Yeah.
I have lots of dreams. The question is, what dreams do we actually work on and execute on and get working?
Yeah.
It's a separate thing. Okay, let's take a look at the chat history here. Folks are waiting for MagTag still. Hugo says, I thought it was writing a CircuitPython honey-do list for me. You wish. Only does Lamore get that privilege because she pays us. She's the one with the to-do list. But she's got really cool stuff. Tim says, I love the enthusiasm about the ESP32 and specifically the S2, but I don't usually use Wi-Fi for my use cases, so it makes me want more M4 support. That's interesting because I feel like our SAMD51 port is complete. I'm not sure what more support for M4s actually includes. But Tim is also talking about the WizNet 5K stuff, so maybe it's that. Tim also says the CircuitPython read the docs are also fairly scary because it seems like everything is deprecated. That's interesting. I wonder if that's because like a lot of the MicroPython stuff is still there.
Yeah, well, there's a lot of things. There are warnings about stuff like that we should probably clean up that say like maybe this isn't. For instance, JSON. The JSON description says maybe this is warning this might not be usable or something, and it's talking about JSON. We have to stuff some of that.
All right. DCD says there was mention of the Raspberry Pi wearing out or corrupting the SD card. Have you looked at this Tanu inspired Piorna shown here with a 256 gigabyte Western Digital drive? Yeah, I was gonna say I inspired that. Is there a source point for all the Learn guides? Yes, we do actually have a GitHub repository that has all of the code in it now. Originally, they didn't do it that way, but at some point we did start doing that, which is awesome.
So Tim, if you open a documentation issue, it would be great because we can it'll be a reminder to fix those places.
Yeah. David G, the GitHub Actions CI is provided for free by GitHub for open source projects, like public projects. Yeah, Foamy Guy points out Google likes to send folks to old pages. Yeah.
We just tried to introduce a robots.txt that'll fix that, but it'll take a while for Google to catch up.
Right. Okay, so let me just cover my CircuitPython 2021. Melissa also posted here, so check this out. Yeah, David G points out if you follow the Learn repo, there are spoilers because you may see us adding code for things that have not been released yet. So just if you like to be surprised, you can wait a little bit. Tim says Google sends folks to 8-year-old Yocto project documentation. That doesn't sound very fun. Would love it if you guys could sell 1-volt solar panels. I don't know.
I don't know what 1 volt is.
I don't know if they exist. But what you can do is if you have product recommendations, you can email them to support@adafruit.com. And that will wend their way to the folks that can look for products. Particularly if you know the product, you just want us to stock it. That's a good way there. Okay, so for me, last year I also had this kind of two component focus. So this was really not, it was really like meant to be like, what do I want to focus on? First one's community, and I went back and read this. I think, if you haven't read this yet, I recommend it. I think I did a pretty good job, but basically like, you have to make a project good, you have to do all the things that are not just code. And I made this diagram showing that like, in order to scale your community, you have to scale like the tiers of your community, like not only the people that are using what you're working on, but also the reviewers and the contributors as well. And this is kind of like my unhealthy community where like it doesn't scale because you have way more users than you have folks contributing. And then the other thing I said was access, and reading back it after a year, it's super vague. And I wish I hadn't been a bit like this vague. It's like, it's true. Like this, what I'm talking about here is like really just like all the tech you see around you, we need to make it easier and accessible, which is true. And that's what we're doing. But really what I want to focus on, like, that's not a very good thing to focus on. Like, that's not focus at all. So this year I did it specifically as mobile, and we've talked about this on the stream, but like I think now, like this is the year for us to do a mobile BLE only and just like BLE on the side sort of workflow. For cases where you have, if you have BLE and USB, like USB should be the kind of primary way of doing it. But I want to start supporting BLE only workflows. And I think the thing that, the microbit V2, the ESP32C3, but then also the ESP32 are really reasons to do that. And so I wanted to call that out. And I also wanted to call out, and I want to just plug it here. I did a talk in February of last year, like, when you could actually go to talks or go to conferences. It's not in a separate video. It's just in this like long stream video. But this, if you click this image or the link here, it's to my talk, and I was the last talk of the day, and I actually rewatched it, and I'm really proud of it. So if you have time, go look at that. It's really this very broad vision of like most of the world doesn't know how to program, and most of the world has phones and tablets, not computers, and therefore we need to provide coding access to people who are only on phones and computers, or phones and tablets. So I'm crossing my fingers we can lay the foundation for a BLE workflow this year, and really focus on the CircuitPython side of it so that people can start building and experimenting on top of that. So yeah, hopefully like even in the first half of this year, I can get to that. Dan, you and I have talked a little bit about CircuitPython 7, and like what are the things that we want to change when we have that break. And we had talked about like changing the blink pattern.
Making it not so busy. You mean,
Right.
yeah. Yeah.
So sorry, I'm moderating YouTube. Whether I like jazz has nothing to do with what we're talking about. So yeah, I think in that moment where we're changing the way that the device interacts with you during a workflow, I think is the same time that we can do the BLE stuff as well. And that will give us more flexibility in what CircuitPython does during sleep as well, which is why we want to do the blinks. We want more flexibility to actually like shut down LEDs when things have failed, in particular. All right. Oh, that's the wrong window. So many windows. Okay, so we're just over an hour in. So why don't we, and we talked about CircuitPython 2021. I should just say, if you're watching the stream and you've watched these deep dives, but you haven't written a CircuitPython 2021 post, please do. Would love to hear, like Tim has been talking about, like, I don't care about Wi-Fi, but I care about Ethernet. That's just really interesting. We're not promising to work on the things that people say they want, but it is really nice for us to get kind of like our finger on the pulse of like what people are doing with CircuitPython, and in particular, what projects you want to be able to do, but you can't. So please, if you haven't done a CircuitPython 2021 post, I think the easiest way is if you have a GitHub account, you can do gist.github.com. And if you do a .md file, it will render it as markdown. I think that's the simplest way. Write it up and then email circuitpython2021@adafruit.com, and it'll go to me and Phil, and I'll post it on the blog along with the list of all the other ones that folks have done, kind of to collect it all in one place. Tim says, I'm always on an island of rare people that want something different than what was assumed. Yeah, and the best way to find the people that are on the island with you is to let people know what you're doing. Which I think, is what I said about it as well. Of like, we may not do the work, but by saying what you want to work on, you might find people to do it with you too. DCD says, mentioning BLE in phones, is it possible to get a Blinka/CircuitPython GUI to run on a phone so people could write code on the phone to interact with BLE devices? Generic type app to allow users to write UI code for the phone. That's not what I'm talking about. I think it's also very interesting, and that's something the Python community more broadly is kind of feeling this, like, Python's only on desktops. How do we move Python itself to phones? So there is, like, for iOS, there's an app called Pythonista. And then I just was listening to Python Bytes, and they had a CubePython, I think is what it is, for Android, that allows you to do, like, automation tasks on Android as well. So take a look at that. I don't think that CircuitPython necessarily has a role there, but it's something people are looking at.
I know. I mean, there are non-Python solutions to, like, App Inventor, so which is a kind of a drag and drop Scratch kind of interface.
Mm-hmm.
And I think it has BLE support.
Oh, nice.
It's only for Android, I think. Yeah.
Okay, and with that, let's kick it over to Dan. Dan's bugs.
Bug.
I feel like bug fixes, I should say. They're my bugs. You're fixing them.
All right. I was gonna talk about some of them they're not on your bugs by any means. But I was gonna talk about a couple of bugs that I fixed recently. We had several bugs, and it looked like they might be the same bug at one point. Time.sleep on Macs, if you typed it into the REPL, it would just hang, and you'd have to type carriage return, and then it would come back again, which was really strange. And then there was another sort of similar bug where just something like a Blink program on Windows or on something else would hang. Like it had two sleeps in it, one after you turned on the LED and one after you turned it off.
Huh.
And that was really strange. And so I was trying to figure out what was wrong here. So I found it was actually 3 or 4 different bugs. And only one of them was kind of directly related to time.sleep.
Right. So what was your, like, when you're starting to look at this bug, what was your, like, where did you start?
I thought it was really odd that it only existed on Macs.
Right.
And I didn't understand that. And what I did then is something called a bisect, which I don't know if Scott has talked about that before.
I haven't.
Or not.
Yeah,
So,
I don't do it. So that tell us your
all right,
ways.
I'll tell you what a bisect is. It's a feature in Git, and it's something that people have done in an ad hoc way in the past. But you say you have 2 versions of a program, and like you say, well, this used to work in version X, and it doesn't work in version Y. Okay, so at what point did it stop working? And maybe that I can look at the code that was changed at that version and see what's going on. So, I used to do this before having bisect support. I would just say, like, oh, well, I've got versions 1 through 7. Let me try 3, and maybe I'll make a guess. Maybe it's in 5, and I'll just try different versions. Mm-hmm. But what bisect does is something really straightforward. It says you mark the beginning and the first bad one, or you mark a bad commit, someplace in the history where there's something went wrong, and you go back in time and you find a good commit, and they don't have to be exactly where it first went bad or first was good. Mm-hmm. And then you tell Git, I want to bisect between those 2 things. So
right.
There's a good one and there's a bad one. And then Git says, okay, I'll let you do a binary search in between. So there's a lot of commits in between. And it says, like, oh, you got 12 commits in between. Let's start in the middle at 6.
Right.
And then so you say Git bisect, and it says, okay, build this one and try it. And then you do it and you say bisect good or bisect bad. And it says, okay. it'll say, okay, well, I'm either going to choose the top half or the bottom half,
Right.
and then it divides it up again, and you do this binary search technique until you get to the commit where it went bad,
Mm-hmm.
and then you can look at exactly what changed in that particular piece of code. So that's what Git bisect is,
Mm-hmm.
and it's really powerful. It can be a little bit tedious. In CircuitPython, you have to sometimes I forget to update the submodules when the bisect happens, and then
Right.
I would go over the wrong set of submodules.
Yeah, that's
But
something we've talked about on the stream before, of how like changing branches doesn't change your submodules.
yeah, but this, for instance, with this time.sleep bug, I was able to do a bisect, and I found that it was when um, Scott had added some sleep features. The low power sleep stuff that he added originally, so that time.sleep it doesn't go into really low power sleep, but it has the processor wait until an interrupt happens.
Right.
And there
Told
was
you
a
it was
few
my bug.
around that point. And when I looked at that, it turned out Scott had changed the tick management. There are these ticks that happen, and they happen every 32nd of a millisecond, right? Yeah. It's the low frequency clock.
It's a tick is 1/1024th of a second.
Yeah. And
Which is weird,
so,
but it makes
so
sense.
I just by inspecting the code there, I had a bunch of questions about the code, and I talked to Scott about it, and I said, there's this weird thing here where it gets passed in as a UN64 gets passed in as a UN32, and it gets set as a UN32.
Mm-hmm.
And I was like, that seems a little suspicious, so I'll just try to change it so that the types match. And lo and behold, it fixed the problem.
Yay.
And I'm still not really sure why, because I thought that the value was only going to get greater than 32 bits if it was running for a long time. But for some reason, it fixed the problem, and it wasn't worth figuring out why.
Right.
Right. So that was one of the easy ones, and that was actually related to sleep code.
Yeah. So Juan Carlos has a question. It says, what bug have you fixed that was the most satisfying to find and fix? I think one of these that you've fixed recently might qualify as that, but if it doesn't, that's fine.
That's an interesting question. Yes.
And Hugo Dahl also...
The most recent satisfying one, not the old one.
Sure. Hugo also points out, bisect is a great example of why you want to keep your commits fairly small. And 10,000% from Tim.
Yes. Like, we do a lot of work in progress commits. Lemore, Lady Ada, is always saying, do it as backup, do a commit and push it. Because you never know if your computer is going to catch on fire or something like that. Right? And you don't want to lose several days' work. Or you might do something horrible and delete your source tree or whatever. That's happened to me a few times in life. And sometimes I can, remember what I wrote, and I rewrite it a little better sometimes, but it still takes a day or something.
Right.
So what ends up happening is that there are a lot of work in progress commits, at least even on a branch or something. And we used to squash those commits, and now we don't do that anymore.
Yeah, that was pretty early on that we decided we would just merge, right?
Yeah. Like, who cares? Who cares about keeping the commit tree clean? Some people really like that because they want to be able to print it out and make it look as if every step that they did was perfect, and that's never true. So don't do that.
I tend to squash my commits before I do a pull request, but after I do the pull request, I don't. Partly because like tracking comments on commits that disappear is really tough. But I do like to squash before that because sometimes I'm changing files that I don't want to appear to have changed at all.
That's a good point. Yeah.
And so I will try, like, because I'm a printf debugger, and so if I put a printf in like some core file, like I don't want that to be part of the history of just me adding a printf and removing it. So I do tend to like squash before I make a pull request, but like after that, I'm okay, like, of keeping the history.
Yeah.
Uh,
And somebody else asked about rebasing. Well, a story I have about rebasing. The previous place where I worked, somebody gave a talk about how great Git rebasing was and how you could use it to clean up your history.
right.
And in the talk, he had a very simple example, and he messed it up. And so I was like, this is not really worth it. Okay. Yes, it
Right.
made his history clean, but it also, I mean, you can do it. You can do it if it's very simple. Yeah, you can do that. That's fine. And sometimes I use a force push or something like that because I left out a semicolon or something.
Right.
You know, maybe that's not worth keeping in the history. But if it's complicated enough that you're going to you could possibly mess up your history by rebasing. And here was this very simple example that he was doing on a toy program. Like, it was just like, it's not worth it. So,
Right. Yeah, I actually tend to use rebase to do my squashing before I make a pull request is usually how I do it.
but you bring a very simple kind of rebase, I hope.
Yeah, I mean, I do it as an interactive rebase, but I like it because I can see all the commits, and if I want to try to like have more than one at the end, I can do that, or I can just mark them as all fix up.
Yeah,
Um,
yeah.
yeah. So we haven't talked about your most satisfying bug, and let's get back to that.
Right.
But
Well, yeah.
you can keep thinking about that. We'll circle back.
Okay.
David G asked, related to the first, the UINT 64 thing, is what you discussed related to the monotonic precision and how it decreases over time? Should we have a way to reset the monotonic, or is there a way?
It wasn't particularly related to that. I know, David, you brought that up about the time alarms are using the float times. Um, our feeling about that, I think, was that the timing on sleep is actually really sloppy right now because it may insert extra time during sleep to make sure that you're not connected to USB. Um, um, so we didn't worry about trying to do precise. We're not asking deep sleep to sleep for 10 milliseconds or something like that. We're asking to sleep for many seconds or minutes or hours.
Mm-hmm. I think
Uh,
for the like monotonic issues, I think one thing we talked about doing is resetting monotonic every time the VM starts.
yeah,
Uh,
we're not doing that right now, right?
no, but I think that's something we could do for 7 as well.
Yeah.
It's one of those things where it's like technically it's not the API and we could change it, but it's probably best to like put it in 7 just to like call it out as something that's changed.
Right, right.
Um,
David also asked, is bisect smart about the size of the commit? Trying to find a place where half the changes are before or after. It just does it by commit. It doesn't care how big a commit is. So if there are 100 commits, it's going to start in the middle at commit 50 between the good and the bad. So because a small change can have a massive impact, right? So
right, right.
um,
All right. Have you what crossed your mind in terms of satisfying bugs to fix?
I think that it was well, in the most recent satisfying one was to explain further about the other time.sleep one. It's that I looked at the firmware map, and maybe I'll share some code here. So if I have a build, and let me say that I'm going to share this. see. Screen share Emacs.
I'm gonna grab my other water behind me.
Okay, yeah. See if I can make this bigger. It's not, I can't just do Control plus.
Super Hot Soup says, I just bought an Adafruit clue, but I had no idea how to use it. We've got tutorials. Yeah. Hydration king of CircuitPython. That's right. Sometimes I even hydrate my keyboard. The easiest way to find the Learn Guide for a product is to go on adafruit.com and find the product, and then usually we have the primary guide. I'm doing it now, but Dan's screen is on, so I don't want to make that go away. You'll see that it's designated as a primary guide, and I'm going to link you to it, which is just learn.adafruit.com/adafruit-clue. But yeah, that's a pro tip if you're ever trying to find guides that are related to products, is you can go to the product page and then look under Learn for all the guides that are mention that product.
Can you hear me, Scott?
Yes, I can hear you.
Okay, you faded out. Audio. Okay. All right. Well, I'll just talk about this latest.
Yeah.
So I was looking at when I was reading the sleep code, I noticed that I was printing out this variable called ticks enabled that Scott had added. It was just a Boolean.
Right.
And when I printed it out, like the code was, it was clear that it was, like when I was tracing the code, it was clear that it should have been false, but it was true. And when I printed it out, it wasn't 0 or 1, it was like 151. And it was like, oh, that's ridiculous. There's no code that should set it to 151, because that's what the compiler doesn't set true values to that. It just uses 1. So I thought, this is getting smashed. Why is it getting smashed?
Right.
So I looked around and I looked in the linker map, which is firmware.elf.map, which comes with every build for free. And I noticed...
Mark, stay. You're fine. Linker maps are fun.
I noticed that it was in between two tiny USB buffers, one called setup packet and one called USB control buff. I was like, well, maybe one of those is, especially the setup packet one, is getting overflowing for some reason.
Right.
So smashed. Well, define smashed. Smashed means something overwrote it when it wasn't meant to be written. Like, you know what we call a buffer overrun. Suppose you had a buffer and it's 4 bytes long, but your code is wrong and it's trying to write 6 bytes into that 4-byte buffer. So it writes off the end of the buffer into the next piece of memory that's past the buffer.
And this
so
is...
some languages have array bounds checking and some don't. If you tried to do that in Python, it would say, no, you can't do that.
Right. And that's known as like memory safety, right?
Yeah. But in C doesn't have bounds checking. So if your pointer is past the end of the array, too bad.
Right.
So it'll just get smashed. You overwrite something. So in this case, what eventually happened, and I talked to Tack, who's the author of Tiny USB. He's on the other side of the world. And so I have to talk to him at 11 p.m. my time, but it worked out. And he said, oh, I think I know this. Did you set this variable in set this constant in Tiny USB? And I said, no. And he said, oh, it should be set to 64. And I'm going to change Tiny USB because that's the default, because you're not the first person who had this problem. So he changed that. And then it also turned out that this same buffer was being used for even after I made that change, this buffer was still getting overwritten.
Oh
And the
no.
way I checked that is with something called a watchpoint. And I don't know if you talked about watchpoints yet.
I don't think we
Yeah.
have.
So breakpoints, everybody knows what a breakpoint is. A breakpoint is when you're debugging a program in a debugger like GDB and you say, stop at this place. Stop when you get to this place so I can look around and see what the state of the world is there. Look at values of variable. A watchpoint is stop when a certain location in memory has changed. So instead of stopping at a place in the program, it's kind of stopping at a place. It's kind of like orthogonal to that. Or
Right.
something.
But we had also talked about that I think this is only if the CPU changes the memory, right?
That's right. So the ARM has built-in hardware watch points, but they don't work if the buffer is being overwritten with DMA. If the memory is being overwritten by DMA, only if the CPU notices that you actually are addressing that piece of memory using an instruction.
Right, right.
So it turned out one of these tiny USB bugs was a DMA problem, and that I set a watch point and I didn't catch it even though it was changing. So I knew it was a DMA problem.
Mm-hmm.
So I talked to TAC about that. And then I saw another case where it was being overwritten by code. But anyways, so I went to sleep and I looked the next morning at the data sheet to see what was going on here. And there's a certain kind of thing. I was reading the data sheet about the USB peripheral in SAMD 21s.
Mm-hmm.
And it turns out that, unbeknownst to both TAC and me, if you say a buffer is a certain size, but something else is another size, it will write, when USB messages get transmitted between the host computer and the peripheral, there's a CRC, a cyclic redundancy check.
Right.
A couple of bytes that it's a checksum of the data, and it can tell you like if the data got corrupted when it was being transferred. So it turns out that the USB peripheral was actually writing the two checksum bytes past the end of this setup packet thing, and they were overwriting TIX enabled. When we figured this out, because we expanded the size of setup packet, which was only 8 bytes long, we made it 128 bytes long and the bug went away. And then we made it 64 bytes long and the bug went away. And then we made it 12 bytes long and the bug went away. So then I looked at the data sheet and said, I see what's going on here. So that was the second fix. So there were two separate bugs that were causing this problem.
Right.
In a row. We could have fixed either one of them and it still wouldn't have fixed the problem. So that was the most challenging. I'm not sure if it was the most fun.
Well, I mean, how did you feel once you fixed it?
Yeah, it was very satisfying to figure this out. So that's the most recent fun bug.
And how many bugs do you think are left?
In CircuitPython.
None. The answer is none. The code is perfect, right?
Yeah. No, maybe not, but 79. I don't know.
Depends on what you think a bug is, I guess.
Well, the first bug I fixed in CircuitPython was in the HID code, and it turned out it was a bug in Atmel's library. They forgot to align something to a 4-byte boundary.
Right. Yep. Yeah, and I had fixed some things in the ASF too. That was part of the reason I was like, why are we using this? And definitely informed, like, there was a time where we used the USB stack from vendor tools. Like,
yeah,
it was a month or two of work to just get us on to tiny USB. I mean, like, if I'm debugging a USB stack, I want to use one that I can use on all of our stuff. And it's worked really well.
Yeah. But tiny USB is fantastic because when you fix a tiny USB bug, it fixes it for everything, and when a new feature is added, it's added for everything.
Right. Yeah.
I mean, the best virtue of a programmer is to be constructively lazy, and to be constructively lazy by using somebody else's.
Right. But in a way that you contribute back as well, because I think, one of my fears with something like Tiny USB is that, like, Tiny USB is used for the ESP32S2, right? But, like, it's part of the ESP IDF, and, like, who knows if they keep it up to date or whatever. Like, I really want this model where, like, Tiny USB and then all the vendors contribute to that versus, like, every vendor having their giant conglomeration of everything.
Yes.
DCD said there's always one more bug. Bruce S predicted infinite, maybe less. Mark says, well, if you fix one, there's probably now 2 more. Tim says, I did statistical analysis on the Linux kernel predicting when there would be no bugs left. Do you want the statistics answer or the truth?
Right, what's the truth?
we got 2 +1s for more Dan on deep dives too. In fact, somebody suggested you doing your own stream with just me as a guest.
You remember this famous Dijkstra quote? Let's see. Program testing can be used to show the presence of bugs, but never to show their absence. Okay.
Yeah, that's a great one. Ooh, David G has a question. David asks, are there Adafruit boards that do USB host and any plans to add that kind of support to CircuitPython?
The hardware will do USB host. They don't have it implemented in Python.
Right. And Tiny USB does have host support, limited host support as well. USB host support is actually a prerequisite for my dream world of supporting the Raspberry Pi 400, which is the like Raspberry Pi keyboard thing they announced. Because that uses USB host, I think, for the keyboard. I think the keyboard's actually connected via USB internally. And Juan Carlos says, Deep Dive 2, dive deeper with Dan. I'd watch that.
Thank you for the alliteration.
Yeah. Yeah, I mean, I this is the first time I get a chance to really highlight the fact that I'm not the only one that works on CircuitPython.
Yeah.
And Dan and I have really, and Jeff compliments me well too. But Dan and I have worked really well together, I think, since Dan came on working full time. I remember getting the email from like Phil being like, what do you think about hiring this person? And I said, yes, like, please. Yes, they're really good. And let it, like, I don't want to have to, like, Dan's way more willing to like get out a Windows 7 box and test drivers and stuff. So, it is really nice that, like, we complement each other really well. And I think, CircuitPython team's been really good for that.
So DCD asks, isn't mouse and keyboard emulation a host? Oh, no, it was answered. Okay. Yeah, it's a peripheral. Mice and keyboards are peripheral, USB peripheral.
Right. So if you're acting like a keyboard, you're a device. If you're talking or getting keystrokes from a keyboard, you're the host.
And there are people, a fellow named Bill Binko has built like a USB filter, which consists of 2 trinkets, one of which is running Arduino USB host code, and the other is running CircuitPython or maybe Arduino USB peripheral code, and he uses it to convert, to basically filter for assistive technology devices. You might want to various things into various input events into various other kind of, and he uses it for that purpose.
Right. Tim says, I wish the Pi 400 had the camera port though because of Zoom. That's what USB's for. I know it's got lots of USB. I know they have the fancy Pi cameras though. Do you have more bugs there, Dan? I think
we have this bug.
See, we talked about 3 of them, right?
Yeah. So those are and I can say what's one in progress. I could share another
Sure.
screen here. So let's see. Let me go back to screen sharing, and I will share.
Oh, is this the one we talked about on Wednesday?
Let's see. I'm not sure if I can make this bigger or not.
Yeah, Paul says S2 is a host, so you can write CircuitPython direct to it with only a keyboard and a really good memory. Oh, you know,
Yeah.
I don't think I showed this Beagle, or not Beagle, basic Python thing that I did.
Oh, you should show that. Yeah.
Is that on this computer? Yeah, it is. Yeah, I'll show that after you're done. I'll blow some minds. Sorry, I'm objectifying you all. Tim says more Dan bugs.
But you want to take a? I can take a break, and you can basic Python.
Okay, so
Python with line numbers.
yeah, so I was thinking, Tim, about CircuitPython on the Pi 400 and how do you edit Python on there? So let me make it a bit bigger. So I have this thing. It's now on my GitHub repo, but you can do basic Python, and then it does this. It says basic Python v0, and it's ready. And so the idea is that you're editing Python code like you would edit basic code. So if I say like hello world, like it says invalid syntax, but then I can say like print hello world, and it prints. I don't think 1 + 1 works. It doesn't like print it out. But then what you can do is you could say 10 is print hello world, which is how, and then it doesn't return in case you want to do another like print afterwards. And then you can hit run and it runs it. And then you can hit list to list the program. So this is how you edit basic code. And then what you could do is you could say like 5 is like for I in range 10. And now if we list again, we can see our program. But if we run it, we'll get an indentation error. David G says, can you do go to 10? No, you cannot. Because, yeah, it's only like 30 lines of Python to do this. So this is the weird, right? Like the code you're writing is Python, but the way you're writing it is as if you were in BASIC. Like there's a stronger split between these two things. So we have an unexpected indentation block, and I think what we would want to actually add is like something like indent like 10 through 20, something like that. Like if we actually ever did this, we'd want that, but it doesn't do anything. But what we could do is we could say 10 is 2 spaces print hello. And now if we run, we should get 10 hellos. The chat's blowing up a little bit. Unexpected Maker says, wow, that's really cool. Tim says, mind blown. Not the line renumbering flashbacks, though. Yeah, I was actually like watching. So I've been watching some of these streams about people making retro computers, like modern retro computers. And something I think they want is like something like this, where it's just like you're typing at a keyboard, you can see it. I actually was like, the best docs I found, there's this one called Mega 65. I don't know if folks know about this, but it's most probably the best computer according to their website. And it's like this old kind of like Amiga Commodore style. Oh, right. It's based on what this Commodore 65 could have been. It's FPGA based, so like the first units they sold were like $1,000 a piece. But they're hoping, I think, to get into like the hundreds of dollars range. But they have a user guide on here under docs, and it's actually like really good. So let's just open that once it's downloaded. So that was like really like I'd never actually programmed in BASIC in the terms of like sitting at a keyboard and doing it. I think I had done like calculator BASIC, but it was never like this like how do I edit BASIC sort of flow. So like this first steps in programming section on here is actually really, really good. And I love this computers are stupid, really stupid. Like it's definitely true. And so this like is the first time I've actually seen somebody lay out like how you actually edit BASIC. And so that's kind of like where I realized like, oh, I could do like I could take the coding parts from it without doing the actual like it runs BASIC part. So yeah, that's pretty cool. And if you just control D, it gets out of it. But it's actually very simple. I think David asked if it would run on CircuitPython, and I'm not sure. If we look at what it's doing, it's very simple. It's like 55 lines of code. But we basically have this like while true, we get the line. We try to figure out if there's a number in front of it, and if there is, we like truncate it and do it. Then we store it to our program. Otherwise, if you list, we print it out. If you run, we run it, and we use exec. And exec, you can give it like top level dictionaries for locals and globals, and I'm not sure that works in CircuitPython. We can certainly add it, but I'm not sure it works. And then I also have save and load. So that would allow you to actually like write Python files out and load them in. And the Python file will have a bunch of empty lines because you want the line number errors to be correct. So yeah, that's a weird experiment and something that like would be kind of cool once we have like Pi 400 support. I think that would be a very neat way to program on it. So that's my basic Python show and tell. And there is a GitHub repository. It's like tan/basic Python. If you think that idea is neat and want to help me with it. But yeah, I think we could we have freedom on the commands that we use to like renumber and stuff. And so I think we could totally have like indent and things as well. Gave everybody flashbacks. So yeah, that's it. That's an idea that's in my back pocket. All right, Dan, do you want to go back to...
Well, I guess this is in the early stages of debugging. So we have this terrible bug that Thea, of Thea Codes, also known as Stargirl, who's doing the Winter Bloom synthesizer, encountered when she was trying to... she has a script that loads up the synthesizers that she ships that run CircuitPython with a bunch of wave files, and they were hanging, and this started in CircuitPython 6. It doesn't hang in CircuitPython 5.311. You try to copy a bunch of large files, it takes a very long time, where it never seems to finish.
Mm-hmm.
So I don't really understand and it seems to be particularly prevalent on the SAMD20 ones.
Mm-hmm.
So I thought it was something like some stuff that we had to do with, Scott had changed the way that 1 millisecond ticks were done, and I thought that the USB code was not being called often enough, maybe, because you're supposed to call something in tiny USB at least every millisecond if there's work to do. But right. I tried several different ways of making sure that the millisecond tick and commented out the WFI the way Scott, and it didn't make any difference. So I'm not still very far along on this, but I took some USB traces, which Scott recommended, and that was a good idea. And there are two ways to take USB traces, you can that is spy on the communication between USB device and the host computer.
Right.
And you can buy a box. There are these boxes you can buy. There's one called the Beagle.
Right.
And it costs several $100s. And if you wanted USB 3, it would be $1,000 or something. And it comes with some sort of crummy software that you have to pay extra for if you want certain features in.
Right.
And there's also Wireshark, which is you probably may have heard of as monitoring network traffic, but it monitors any kind of packet stream-based traffic as long as there's a plugin to do that.
Right.
So there's something called USB Mon on Linux, and there's something similar called PCAP on Windows that lets you monitor traffic.
Mm-hmm.
So I set it up on Linux to monitor the USB traffic. And I did it. It turns out that these delays, these writing delays don't happen if you have a connection open to the REPL. It doesn't matter if you're actually in the REPL, it's just you have to have a serial connection to the board. So that was weird. So I did one, I would start Wireshark monitoring, and then I'd do this copy a bunch of files to the board, and then I would turn it off. And so I've got some traces that I want to compare. And I haven't really spent a lot of time, I haven't had a chance to do that yet. So I have the bad case and the good case, and I'm going to compare the two traces. But one really interesting thing that I noted really early is that if you look at this, this is a dump of the trace of one of the bad traces. And if we look, let's sort this by protocol so that we get, actually, let's sort it by length. So I was copying some big files. And here, like these files were like 30K, 80K kilobytes or something like that. And what did we see here? We see that if you look at the trace that's good, you see these big transfers. But here there are twice as many, or almost, and some of them are repeated. So here's 43,584. That's a whole file. And here it is again.
Right.
And it doesn't look like that in the good case. It only looks like that in the bad case.
Huh.
So there's something funny going on. And this is sorted by size. You can sort things in USB Mon,
right,
in Wireshark by all the columns that are here.
Right.
So this is a clue. Okay, that's all that I know so far. But it's obviously there's something really weird going on. Like the host is trying to send it and it thinks that it failed and it tries to send it again. Maybe, I don't know. I'll have to find out. But so we're in the very early stages of debugging.
Yeah, I mean those are big files.
Yeah.
But they are sent in chunks. Like this is and Todd was talking about using the Beagle, and the Beagle tends to be my preferred way to do it because there is like the Wireshark PCAP stuff does have like, it gives you the Linux kernel view of the world. It doesn't necessarily give you like on the wire view.
Right.
And like I prefer to do the on the wire stuff, but what you're pointing out here is also that you're seeing all the SCSI stuff analysis on there, and that's something that the Beagle program doesn't do automatically for you.
Right. And the other thing the Beagle didn't do was it didn't interpret HID descriptors. So when I was debugging HID, the Beagle was not, unless you paid extra.
Right, if you have one of the better ones.
Yeah. So I'm kind of just used to using Wire. I use Wireshark first.
Right, right.
And I go to the Beagle if I need to.
Right.
So anyway, there's something really strange going on. So mass storage devices on USB mass storage devices, you talk to them using a subset of the SCSI command language. And SCSI is an old protocol that was used for external disks. And it's still, maybe they use SCSI over what is it called now? Over SATA. I don't know. But anyway, this is just the next bug to look at, basically.
So what are your next steps?
I'm going to look more carefully at this trace and see what is actually happening, because as I said, these things actually aren't consecutive. They're
Right.
separated. If you look at the time here, you can see like, in fact, these are in opposite. This one is at 1329. This is at 1359. So these are 30 seconds apart. Actually, this is kind of interesting. They're exactly apart. So that's like maybe some timeout that's happening on the host side.
Right. Yeah, and it looks like each file had that duration.
Right. It's not exact. I mean, it's almost exactly 30 seconds apart. So yeah. So there's something really. So there's something. So something is probably the tiny USB is not responding in time for some reason, because we are forgetting to ask it to do something, or it's not aware that it needs to do some work or something. We're not really. I'm not really sure. But I
Right.
just did this like a few minutes before
Yeah.
the live stream, so I don't know what's going on yet.
Right. Um, yeah, DCD asked, would your dream programmable FPGA tool be able to handle USB sniffing? And then Bruce S points out, isn't Luna a project in the works for FPGA assisted USB stuff? And the answer is yeah. Like the great Scott Gadgets folks, Kate Temkin in particular does amazing stuff. And the Luna looks to be like, it looks to be the cool way of doing it in the future. I think one of the challenges with launching hardware is software support, and there's very early software support for Luna. Last time I looked, which was a while ago, but it's really something that like, we talked earlier about like CircuitPython in the community and how you have to do everything else. Like that's true for the Luna stuff as well. It looks really cool. The hardware is really cool, but like there's always more work to do with that, in terms of writing instructions for how people get going, and then writing the code to do it, and the analysis stuff and all that. So yeah, I would love to move to an open source solution. And Kate's been doing some amazing stuff with like USB 3 on the Luna. So like I think it would be really, really cool to be able to get to the like, here's a USB tool and it does like most of the USB stuff. I was looking for something to do high-speed USB analysis, because like we have the IMXRT support in CircuitPython, but it's kind of been, along with the ST support, like not something we've focused on. And I think high-speed USB could be really cool. So and the Beagles that I think both Dan and I have don't do high-speed USB. So, what is the solution for us for debugging that when we get to that point? And I think Luna is a good thing to look at. But I don't know exactly where it's at, whether it's production or whatever. But yeah, I love all the open source FPGA stuff. That's something I'd love to do at some point, but it's just like complicated and expensive. Although it gets better every time. It's getting better and better, which is really, really cool. All right. Are there other questions folks have? We've got 5 minutes till 4 o'clock, so we should just about wrap up. I don't want to keep Dan because he's 3 hours later than I am, so I don't want to keep us super late.
Yeah, I had a snack, but no dinner yet. So
yeah, I'd need to have a snack and then go get dinner. And it's Friday, so do you want to just talk, kind of wrap up with just talking about RC1, which I saw that you released this week as well?
Sure. We hope that there were a lot of bugs fixed between RC0 and RC1.
Right.
More than we expected. So 6.1.0 RC1, it has, for instance, still has this file copying bug in it. And I don't know that I'm going to get to that, but we would really like to get 6.1.0 out final, even though it has known issues, because those problems are also in 6.0.1.
Right.
So it's not worse. it's better in a number of ways. And because the mag tag doesn't even have, there isn't a stable release for the mag tag because the board came out after 6.0. So we like to be able to point people at a stable release.
Right. Yeah. That's been kind of like a support tax, is like,
yeah,
why are you trying the stable release on the S2? We're trying to tell people not to use it, but getting 6.1 out will make that a lot better.
Right. And in fact, that's another that, yeah, we did the Metro ESP32S2 came out, and it does have there was a build for it on 6.0 and 6.01, but we don't really want anybody to use it because it's way back in terms of ESP32S2.
Right.
So if you have a chance to test RC1 over the weekend or something, that'd be great. If we don't hear from anybody or there aren't any significant bugs, then we'll try to release it early next week so that we can move on.
Yeah, I think 6.2 is gonna be cool too.
Yeah.
So by getting 6.1 stable, we can change some more stuff in the core and then release that as a like pre-release for 6.2. And one of the things we've been thinking about for that is like the TCP server stuff that Lucian's been working on, aka Higher Effect.
Right.
Okay, we got a couple other things. So Bruce S asked, "What is the copy problem?"
I'm just finding the issue for that.
Yeah, it's copying large files delays or hangs the board over. And David asked, have you bisected that yet?
No.
It's a pretty big range, right? That's like...
Right. I know it's okay in CircuitPython 5 and it's not okay in 6. Right. And it's broken in 6.0 and 6.01.
Right. So there's that. Juan Carlos said, I just remembered about your microprocessor jigsaw puzzle. How is that going? I finished it over the holidays. I was missing a single piece, and I suspect the cats are to blame because I put it out on the coffee table in front of the couch, and the cats step on it. And the pieces stick to their paws, and they shake them off, and they go flying. So I think the cats are to blame for the one missing piece. So it's basically done. I actually have it right up behind me. There's two puzzles right here. It's not, you won't be able to see it. But the current puzzle I'm working on is actually a puzzle of pictures of the cats that Becca got me for Christmas. So if they lose any of those pieces, it's on, like, they're the ones that suffer because the pictures are of them.
You said it was an 8008, is that right?
Yeah. Yep.
So this here is an actual 8008.
The camera wants to focus on your face.
Let's see if I can. Yeah, there we go.
So how did you come about this actual chip?
And I never did anything with.
You got it in high school.
I got it in high school. Yeah. I wrote a letter. I was reading Electronics Design magazine in high school, and there was this column by the president of Intel, and he said, now that we have a computer chip, blah, blah, blah. And I said, what? So I typed up a letter on a typewriter, and I said, could you tell me more about this? And they sent me a data sheet, and then they invited me to a product seminar, and it happened to be on a school vacation day. So I took the bus, and we were living for 1 year. Normally, I grew up in Tennessee, but we were living on Long Island. And I took the bus to New Jersey, like multiple trains and buses, and I walked a mile to this holiday Inn. And somebody from Bell Labs was there, and he gave me one of these chips because they had given him a sample, and he invited me to Bell Labs. But it wasn't the Unix people; it was somebody else. We had a different time-sharing system. So,
of course.
But that was fun.
I just remember. I remember one conversation you and I had about like, oh, that was back before a byte was 8 bits.
Yeah, I've worked on a lot of 6-bit byte machines
That just like blows my mind.
and 7 and sometimes 9. Yeah. 36-bit words or whatever. Yeah, before there were bytes, before memory was was addressed by bytes.
Right.
And octal, like I know octal, like all these 4,000 is something in hex, and I can never remember what it is, but I can tell you what it is in octal probably.
Okay, I thought I would actually try to get the puzzle down since it should be actually like not too bad to show.
There's 8, well, right, 8 bits, but before they used lowercase, you could use 6 bits for byte for characters, like key punch machines. Tim asks, 8 bits is a byte, not necessarily.
So the missing piece is here. It won't work. The board won't work because of the missing piece.
You think you could? Are you going to? I'm sorry. Did you say you were going to manufacture a piece?
Sorry, I couldn't hear you.
Okay.
I could only hear you when I have my headphones on.
Do you think you could manufacture a piece?
I meant to look on the website because I got it from Ravensburger, and I think the system that I ordered it from is also a system that you can actually like order missing pieces from.
Okay.
I don't think I care that much.
I mean, you could, if since you know what the original image is,
Yeah. Yep.
you could pick that out, and you know what the shape of the piece is, right? So,
I do. Yeah, I don't know what happened to it. I was a little like, especially after like multiple times. I think like I knew enough about the shape that I could like try all the ones that would fit in there.
okay.
And it's like, well, I tried all of the ones that should fit in there, and I do not have that piece. So, and then I finally finished it and was like, okay, I didn't miss it. Like I straight up don't have it. Okay, there's one last question. Let's answer. Tim was very patient. Said, a weird thing to troubleshoot. Actually, let me take a time code. A weird thing to troubleshoot using D12 and D11 pins for a latching relay on the Feather M4 Express. After switching the pins, a minute later the program reloads once. It does not reload again. When you have phantom reloads, one thing to check is, are you connected to USB? Because if you're connected to USB, your host computer may randomly decide to write to the flash, and that will trigger a reload. If you're not connected to USB, then that's weirder, and I would actually suspect something like a power issue that would cause the reload. But yeah, I think generally file an issue. With things like that, if you have issues, file an issue, and then we can see if other people can reproduce it as well. And if they can, then that definitely sounds like a problem that we can fix. All right. Let me take a time code. Dan, do you have any parting words for us? I think we'll probably do this again, but definitely not every week.
Yeah.
The way we talked about it is like when Dan has interesting stuff he's been working on, he would stop by, and he also doesn't have to stop by for the whole time as well. So I'm gonna try to have more guests on. But do you have any thoughts you'd like to tell the crew?
No, just thank you for having me on. It was a pleasure to talk about how to think about bugs and things like that.
Yeah, speaking of which, Tim did follow up and say, I was curious how to debug that on my own. Serial debug. So I generally, if you want to debug something that only happens when USB is not connected, I use a debugger. And you could like break the second time it reloads, for example. And yeah, maybe printing out to a UART. I don't know. It's pretty tricky. Tim wants a Brent session.
That'll be good.
That would be good. Brent does stuff that I do not pay attention to, so I would learn a lot as well. So yeah, if you have suggestions, you can always email me or mention me on Discord. With wrap up, Dan and I are both on the Discord server, so you can join it, adafru.it/discord. That's where we talk about CircuitPython development each and every week. We have a community meeting on Mondays where we have kind of like more of a like group discussion about how things are going. This has been a deep dive. Next week's deep dive will also be on Friday at 2 p.m. Pacific, and there's a chance we'll have a surprise guest next week as well. I don't want to commit anybody to anything, but this is a good first run to see if I can kind of like understand how to do it. So there's a chance there's a guest next week. It's regular time. Join us on the Discord. Support Adafruit to support Dan and I and the other folks that are paid to work on CircuitPython as well by going to adafruit.com, purchasing stuff. Pro tip, if they're out of stock, check DigiKey, because DigiKey is a really good partner with Adafruit and helps Adafruit out a lot as well. And I think that's it. Thanks again, Dan, for coming on and being my guinea pig for having a guest. It's been wonderful to work with you for the last 3 or 4 years, whatever it is.
Same here. Thank you. Yeah.
And hopefully we'll get more folks to work with on the core over time. All right. And with that, have a great weekend, everyone, and we'll talk to you next week.